Let's see. So our function f of x is negative 2x squared plus 4x plus 6. The first question here, to find the values of x at which this function curve crosses the x-axis. Before I even do that, it's really important to keep in mind that when any function crosses the x-axis, at those points, the y-coordinate is equal to 0. Okay? That's always going to be true. If we're speaking of an x-intercept, then we're dealing with y values, or y-coordinates, I should say, of 0. That's also why on your calculator, to find them with your calculator, you literally use the function called 0, because those are the function's zeros. Now, getting that out of the way, though, to find them, if I copy f of x, which equals to negative 2x squared plus 4x plus 6, but I'm going to replace f of x by 0, that's going to become 0 equals to negative 2x squared plus 4x plus 6. Okay, that's for question 1. Now, at this stage, it doesn't even look like a functions problem anymore. There's no y, there's no f of x. This is a, dare I say, standard quadratic equation that you have to solve. There are many ways of solving it. You could do it by factoring. You could do it using the quadratic formula that's in the formula list. Or you could do it the way we saw last year, which is using delta, right? Now, delta in this case, remember, delta is always going to equal to b squared minus 4ac. For this particular quadratic, what's a, what's b, and what's c? What do we have? We've got a equals negative 2, b is equal to 4, and c is equal to 6. Yeah? So replacing a, b, and c by the values we have here, that quickly turns into delta is equal to 4 squared minus 4 times a, which is negative 2, times c, which is 6. That's equal to 16 minus negative 8 times 6. That's equal to 16 plus how much? What's 8 times 6?
48.
Right. Okay. So you end up with delta, which is equal to 64. Now, hopefully you notice right away that that's a square number. That's 8 squared. Yeah, 8 squared. And I'll quickly box that because I'm going to need that in around, 20 seconds. Now that I've calculated delta, I'm in a good position to actually calculate the solutions to this equation and say x equals to the opposite of b plus or minus the square root of delta over 2a. That becomes, remember, we have our values here, a, b, and c. So the opposite of b, that's going to be the opposite of 4, or negative 4 if you prefer. That's negative 4 plus or minus the square root of delta. That's the square root of 64. Over 2a, so that's 2 times negative 2. We're okay with that? Mm-hmm. Good. Now if I move this up a bit, there we go. And I'll scroll back down later on. That's equal to negative 4 plus or minus 8 over negative 4. That's, if I divide throughout by negative 4, that's 1 plus or minus 2. Okay with that? So ultimately, we can state that x is either equal to 1 minus 2, which would be negative 1, or that x is equal to 1 plus 2, which would be 3. Those are the two values of x at which the parabola crosses the x-axis. Yeah? Now, with that in mind, let me see if I can, it's going to be difficult to fit everything on the screen here, but I'll give it a shot. I'm now in a position to move on to question 2. Now, question 2, we're told f of x can be written as f of x, which equals to negative 2 times x plus p squared plus q. And as I was mentioning, the danger here is that Cambridge IGCSE exam questions often write the vertex form this way. And as I've mentioned, that's not proper vertex form. We saw in class, and you should have in your notes, that when written in its proper vertex form, the parabola's equation should be y equals to a times, in parentheses, x minus h squared plus k. Okay, we've seen that. Now, h is equal to negative b over 2a, okay, which we'll work out in a minute. And k, well, to find k, all we have to do is plug whatever h is back inside our equation, our f of x that we were given in the question, right? Let me see if I can make that fit. Back inside the original function that was given, so back inside this one. We'll also see, by the way, in a second that because we already have two roots, there's a much quicker way to find what h has to be, and I'll show you that as well. Yeah, and thanks for pointing that out. Yeah, you're absolutely right. I could also highlight the fact that because we've calculated delta, another way of calculating k is just by saying that's negative delta over 4a. So if you're good with formula, and I know some of you are, those two formula can be used. Okay. Now, for now, though, let me just use h equals to negative b over 2a to figure out what h would have to be. Since b is 4, that's going to be negative 4 over 2 times a, which is negative 2. That's negative 4 over negative 4. In other words, h equals to 1. Yeah? Done. Now that I know what the x-coordinate of the vertex is, I turn over to my function, which I have at the top here, and let me make that really obvious by boxing it like that. That's my function. I'm going to replace the x's I have in this function by 1. So let's see, that would be, basically I'm calculating f of 1. That's going to be equal to negative 2 times 1 squared plus 4 times 1 plus 6. Clearly, that's equal to negative 2 plus 4 plus 6. And by all means check, but that's equal to 8. So f of 1 equals to 8. And so k equals to 8. Okay? Now, with those two values, h and k, alongside the value of a, which we already knew was negative 2, we're in a position to write our function in vertex form. And I'll write it up here. We can state that y is equal to negative 2 times x minus 1 squared plus k, which is 8. Okay? That's the proper vertex form for this quadratic. All right? Now, as I said, though, remember that in our notes, we defined the vertex form this way, as x minus h in parentheses squared. In Cambridge exams, they often write their questions like this, with x plus some number. Okay, here I wrote p. They could have written h, m, a. It doesn't matter what they call it. They usually write plus something. So to figure out what p and q are, your job now consists of comparing what we just boxed in red to y equals to negative 2 times x plus p squared plus q. And hopefully you'll agree with me that p must therefore be equal to negative 1 and q must equal to 8 to answer that question. Does that make sense? Mm-hmm. Okay, that's how to answer that. Okay, always fall back on the fact that you are aware that that is basically the vertex form. So step away from that, find the vertex form, write your parabola in its vertex form, and compare your answer to the question that was given. Okay? Let's see. Yeah, just for the sake of illustrating the formula here, we haven't done that in a while, but it's worth reminding you of the fact that that formula works. If any of you have family members who went through French high school, that formula we had to know. And it's very convenient because typically when you're studying a quadratic function, you're usually required to calculate delta as we did there. So it allows you to quickly, since you've already got delta, it allows you to quickly figure out what the y-coordinate of the vertex is, using the fact that that would equal to the opposite of delta, so negative 64, over 4 times a, which would be 4 times negative 2. That's negative 64 over negative 8. In other words, k is equal to 8. So I'd get the same result, of course. Okay, just a really nice and quick way of doing that. Another thing I'll point out, and carefully, not everyone thinks of this. To find the x-coordinate of the vertex in this case, we could have actually used the two zeros, the two x-intercepts we had before. And if I quickly make a sketch to convince you of that fact, imagine I have a parabola that crosses the x-axis twice, here and here, and I'll say m and n, right? Then the vertex, if you think of just the symmetry of the parabola, the vertex has to be right here, right in between m and n. So the vertex, which remember has coordinates h and k, well, h I could be absolutely certain is going to be m plus n over 2. It's going to be the average. So if you happen to have already calculated the x-intercepts, as we have here, you're in a good position to speed things up to quickly state that, okay, h is equal to negative 1 plus 3 over 2. And I mean, by all means, check for yourselves, but I could have also done this h over here. H equals to negative 1 plus 3 over 2. That's 2 over 2. H equals to 1. That make sense? That I'm using the symmetry of the parabola there alongside the fact that I know that this particular parabola crosses the x-axis twice. When that happens, definitely use that result. It's really, really useful. Okay? I'll carry on. Let me erase all that. There we go. Now, question 3, provided you know what the vertex form is about, is a very easy question. You have to state the coordinates of the parabola's turning point. Turning point means either a maximum or a minimum. Doesn't matter which of the two. But ultimately, a parabola has one, and ours will have a maximum because the leading coefficient a is negative 2, so our parabola will have a maximum. Its coordinates, this is for question 3, its coordinates will therefore be 1 and 8. Those are the values of h and k that we just found. Right? So those are the coordinates, 1 and 8. Done. Question 4. Provided you know everything that you need to know about your parent functions and all the rest, this one's actually quite straightforward as well. You need to state the domain and the range. Well, the domain for any polynomial function. Now, let me be crystal clear as to what that is. As soon as you have a function which is basically a collection of powers of x, for example, ax cubed plus bx squared plus cx plus d, or a parabola, I could have y equals to ax squared plus bx plus c, or even a linear, right? Y is equal to ax. And I could carry on. I could go into powers of 4, 5, 6, and so on. All of those functions are from a family called the polynomials. We'll learn more about those at IB. But all of them have the same domain, which is all real numbers. Okay? There's not a single value of x you can state or name that I can't comfortably put inside this function and calculate. It won't lead to a denominator being equal to 0 or a negative under a square root. Polynomials are some amidst the friendliest functions there are. Okay? For the range, on the other hand, here you gotta think carefully. Okay, let me just erase that again. Oops. For the range, since we know that this particular parabola has a leading coefficient a, which is equal to negative 2, that tells us that we have a concave down parabola, or if you wish, an unhappy parabola. Okay? It therefore has a maximum point. So the turning point we have with coordinates 1, 8 is a maximum. The range will therefore consist of all the values less than or equal to 8. Remember, the range, you're looking at the y-coordinates. Since the maximum y-coordinate on this parabola is 8, the range will be everything less than that. So for the range, you would state it's equal to all numbers from negative infinity, not included, up to 8 included. Again, I know some of you will use a different notation. You could also write that as this way, with the parentheses and 8. And some of you may also just prefer to say, yeah, the range is y less than or equal to 8. All three of those notations would be awarded full marks. Okay? We're nearly there. Question 5, you need to state the equation of the parabola's axis of symmetry. Now, hopefully you can appreciate that first of all parabola, or I should say parabolae, have an axis of symmetry. But furthermore, that axis of symmetry has to run through the vertex. Yeah? It's a vertical line, so it has an equation x equals to something, and that something, since we've already found the vertex, well, that something's going to be 1. So the axis of symmetry has an equation x equals to 1. End of story. Now, if you've forgotten, we had seen last year that the axis of symmetry is given by x equals to negative b over 2a. So if you're after a formula, that's the formula for the axis of symmetry. But just as I write it and as you look at it, that should be ringing bells. because we've just used the exact same formula over here for h. It's the same thing. So when you're finding the x-coordinate to the vertex, technically you're also finding your axis of symmetry. Yeah? So I don't need to recalculate that. I already have. It's over here. Negative b over 2a is equal to 1. So my axis of symmetry is a vertical line whose equation is x equals to 1. That's all there was to do there. Okay? Last, but of course, far from being least, you need to sketch the parabola y equals to negative 2x squared plus 4x plus 6. Now, this is why, let's say at the IGCSE exam, they ask you to sketch it all the way at the top of a list of questions. I know I said it earlier on. I'm going to repeat myself again and again and again. Don't sketch it till you've done till you've worked out all these key features and points. It'll potentially cost you so much if you do. Always leave the sketch till last. So let's go for this. We have two x-intercepts. We have a vertex. What's the y-intercept for this parabola? Where would it cross the y-axis? 6, absolutely. Yeah, if I copy that, remember, the parabola's equation is y equals to negative 2x squared plus 4x plus 6. The number we have at the end here, that's the value of y at which it crosses the y-axis. To convince you of that fact, to find the y-intercept, I replace the x's by 0. And if you replace x by 0, this whole thing equals to 6. Right? Very similar, in a very similar way when we want to find the x-intercepts, we replace the y by 0 and solve for x. Okay? So I now know all I could possibly need to know, really. So I'll just quickly draw an x-axis, and I'll show you how I do it. Remember, this is a sketch. The scale doesn't matter at all. All that matters is the shape and that you are, dare I say, labeling or annotating key features. So I'll draw a parabola like this. Remember, I know it's concave down because the leading coefficient a was negative 2. So it's an unhappy parabola. Notice that I've just drawn it. I don't have a y-axis yet. That's deliberate. I'm deliberately doing that. I find it easier to place my y-axis after. Its x-intercepts are negative 1 and 3. Okay, so that tells me that the y-axis is going to be closer to this x-intercept. Yeah, so I now draw my y-axis like that. That's y. I'll label the origin. There we go. It crosses the x-axis at negative 1 and at 3. Its vertex, well, it's the maximum point or turning point, has coordinates 1, 8. And it did ask us to find the axis of symmetry, which strongly suggests they want you to sketch that as well. So do. For the axis of symmetry, I would do something, I wouldn't make it a solid line. I would always make it a dotted line, something like this. Of course, you have a ruler, so it should look a little better on your papers there, but this would be x equals to 1. One last thing I'd have to add is my y-intercept right here. And as we said a minute ago, that's going to be 6. So it crosses the y-axis when y equals to 6. And I'll label that right there. We're okay with that? That covers it all.